these equations, we're doing the same thing over and over again. We're starting off with our graph. We need to factor completely. So the top is just x plus 3, but the bottom is a difference of squares.
Sorry for the interruption. If you are participating in sources of strength, you need to go to the library now, please. So if you had already signed up for sources of strength, please go to the library.
I'm going to leave some space here because I hope you can see that the x plus 3's are going to cancel out. So I'm going to write the simplified version, but our non-permissible values, we still have negative 3 and positive 3 as our non-permissible values. If a non-permissible value cancels out, which happens here with the x plus 3's, then you should write the new equation that's simplified. And I'm going to write that new equation and put a green box around it. Number one mistake, this is a good example to do for practice, because the number one mistake that students write is they just write x minus 3. But the x minus 3, do you see that it's in the denominator? It has to stay in the denominator. But then what do I put in my numerator? I put a 1. This thing's simplified. It doesn't mean, if they cancel out, it doesn't mean you're going to have none or 0. You still have, it simplifies to 1 over 1. So we have a 1 over. I'm putting a green box around that because this is our simplified equation. So what do we know? We know that we're going to have a whole, and the one that canceled out was the negative 3 one, and we're going to have a vertical asymptote at x equals 3. How do we find the y-coordinate of our whole? We take the new equation, the green one, and we plug it in. I can plug in negative 3 now. Negative 3 minus 3 would give me 1 over negative 6. Now, we do everything moving forward with what's in the green box. If something simplifies, you can ignore the original equation and just work with the equation in the green box. You're going to have to graph that. It's still a rational equation. We've already done the non-permissible values. Next thing you have to do with a rational equation is determine, is this one have horizontal asymptotes or oblique asymptotes? And in this case, because the degree is bigger on the bottom, technically this is a degree of 0, this is a degree of 1. You can tell the degree by the biggest exponent that exists, and this is like an x to the 1. We call that a degree of 1. The top one has no x's. We call it a degree of 0. So because it has a larger degree on the bottom, whenever the degree is larger on the bottom, you have a horizontal asymptote at y equals 0. So we can start sketching our graph. We have a vertical asymptote at x equals 3. And we have a horizontal asymptote at y equals 0. We also know so far that we're going to have a whole at negative 3, 1 over negative 6. So we go to our nice points. We always want to find our y-intercepts and our x-intercepts. Y-intercept is the easiest one. You plug in 0 for x. And in this situation, again, you're not going to the original equation. Now you're going to that equation in the green box. Plugging in 0 for x would give me 1 over negative 3. I can plug that point on my graph. For x-intercepts, plug in 0 for y. Again, we're plugging it into the new equation. The only place a fraction equals 0 is when the numerator is equal to 0. When is 1 equal to 0? Never. 1 is always equal to 1. Never equal to 0. So we know that there are no x-intercepts in this graph. Do we have enough to graph the blue section? This section you have points, it has to look like this. Do you see that we have no points in this section? So I need to find another nice point. I'm going to plug in 4 for x, and I would get 1 over 1, which is just 1, so I can plug in 4 comma 1. And we've got our graph. And we graphed this graph completely with the instructions for a rational graph. You could have also, notice the green box, we did this graph in our transformations unit. Can you see that this is a 1 over x graph moved 3 to the right? Your 1 over x graph had two asymptotes at 0 and 0. If you moved it 3 to the right, does it make sense that you would have had 1 at 3, but the other one's still at 0? The 2 points from your rational graph would have been 4 comma 1, and you would have also had 2 comma negative 1. My scale is a little bit off. That's how you could have graphed it as well. You could have just said, I'm going to take my rational graph, move it 3 to the right, and add the whole to the graph. Or, if I forgot how to move things left and right, or I didn't recognize it was a rational graph, I could still use my steps, right? Find my x-intercepts, y-intercepts, find my nice points, and graph it that way as well. So what's happening is sometimes we learn a new technique, and now we have 2 different ways we can do the same thing, and both would be right. If you had graphed what's in the green box using transformations and added the whole, perfectly fine. If you had done it with rational graphs and just nice points and drawing towards the asymptotes, perfectly fine. Okay. End the video here.